Hello, everybody, and welcome to this new webinar. My name is Charles. I'm a co-founder of LabV, and today I want to talk with you about something that is very important and is being very difficult to handle for some lab experts, which is how to decode lab connectivity and making comparison of connectivity standards. This webinar is being recorded, and the video is going to be available as an on-demand just right after, in a couple of hours after today's presentation. So there is going to be a possibility to ask questions at the end of the webinar as well. Just for that, use the Q&A function as soon as we are end the presentation. What do we want to do today? Well, first of all, we want to understand why connectivity is becoming increasingly important and relevant in the lab. Also understand which standards are we talking about, which ones do exist. Also understand what the added value of a connected lab could be, how to select the right technology, and I would like to share some learnings with you about connecting lab equipment from projects with our customers. For those who are not familiar with LabV, LabV is a software company, part of the Net Group, and we are making data in testing labs available, accessible, and analyzable. If you do a quick research online about lab connectivity and lab standards, you will figure out that it's kind of very confusing. The amount of information online about digitalization and standards is very huge, and there are so many different sources that often provide incomplete and sometimes even contradictory information. Many of the technical terms and also the details are difficult for newcomers to understand because we're not supposed to be experts in that. In addition, there are often no clear and also no uniform guidelines, which makes the orientation generally very difficult. When you visit trade shows, for example, you can have in-depth discussions with providers or even have a look at talks on specialists or more specialized forums. But it's kind of also intimidating, right? Some are talking about Lab 4.0, standards, connectivity, digitalization, data exchange. It's a little bit difficult to find a way through this jungle, which is a little bit our motivation for today. We want to try to help to gain an understanding, and to do so, there is a couple of information that are very important to have a look at first. First of all, data is not always data. What does it mean? Well, usually data is typically divided in two categories: the operating data and also the measurement data, which is on the left and on the right side of this picture. Operating data is typically, when the machine is running, when a testing device is running, the information on the status, on the performance of the device. And on the other side, it's measurement data is related to anything that has to do with the actual measured values of a property and the result that are generated. But actually, there are also other categories or even subcategories of that are relevant for a testing lab, for example. We can talk about the metadata. These are all the information about measurement data itself. For example, we can talk about the timestamp, starting date, starting hour of a measurement, the measurement location if you have different rooms or even different buildings, these kind of data. Quality data is more the data relating to the quality and the accuracy of the measurement. So it could be, for example, date of the last calibration. And finally, another subcategory could be environmental information, which is here more the conditions during the measurement, the surroundings of the testing device. So for example, if you measure temperature in your lab or the humidity in the room, these are information that are part of it as well. So as you can see, if you look at how to connect data with something, you have to be more specific and know exactly what kind of data you're talking about. On the same way, laboratory is not a laboratory because to bring equipment into a network is a different story, whether you are in the pharma or life science industry or in another industry like chemicals polymers, or even a rubber industry. Why? Because the lab in the pharma industry, for example, it differs in several aspects from other labs. Very often, pharmaceutical and life science labs are actually subject to strict regulatory requirements that affect all aspects of lab work. In addition to that, quality assurance takes a huge center stage to ensure that all products are safe and effective. Every step of any development and manufacturing process has to be thoroughly documented and validated, and therefore the specialized measurement analyzing equipment is generally used as compared as to the traditional industries where they use more standardized equipment. And due to the requirements on these industries, they need completely different data and also more data than other industries, which is why, for example, interfaces or data formats, even standards, completely differ. Here you can see just two visualization of what I'm trying to explain. In the life science industry, you have more connected equipment that is an actual equipment made to measure, whereas in other industries, you just buy equipment from the shelf that comes usually with the software, which makes life much easier. Now talking about some definitions, because I think we have to set up the stage. Are we talking about the same things, right? The first definition that's important is connectivity. Connectivity is really the ability of a system, a device, or even a component to communicate and exchange data with other systems, devices, or components. An interface is the point of interaction between two systems, for example, and that's the point that enables the data exchange. A protocol is a set of rules that control the communication between the systems, and the API or interface is a collection of definitions and protocols that enable software to communicate with each other. So here's more the communication, not from system to machine, but more from software to software. Another very important definition, data integrity. Data integrity means that it's about the accuracy and the completeness of the data during the whole lifetime and not just during the exchange. Data interoperability describes the ability of different systems and devices to work together and exchange information, meaning it allows a seamless integration and communication between different lab devices, for example, or softwares. A middleware is a software that connects different applications to enable a seamless communication and also data transfer, which means that the middleware is kind of facilitating this integration of devices and system by harmonizing different protocols and data formats. And finally, a word that I've been using already, standard. A standard is an officially recognized and also established rule, a guideline, a specification that specifies how something should be performed or manufactured to ensure consistency. It serves as a reference point for any industry or technologies to ensure that the services, the products, or even the processes work effectively and efficiently and are compatible with each other. So this is for setting up some definitions that we're going to use in the next upcoming minutes. And I want to talk about three different categories of important words and technologies in there. The first one will be the standards. A standard is basically what defines how devices communicate with each other. And if you have a look at it, it's between your lab equipment and the software or systems, right? And you have different standards. Here are some of them mainly defined, but it's for sure not an exhaustive list, but I guess it's probably the standards we learn or hear the most about when you do some research about connectivity. And to give you an overview of the most important ones, OPC UA, so it stands for Open Platform Communications United Architecture. This is an open interface. It's a data exchange standard that's usually used in industrial communications of any type. So it could be machine to machine, could be PC to machine, for example. And this open interface standard is independent of any manufacturer or system provider, completely independent of the programming language in which the software has been developed, and also independent of the operating system. So it helps basically different machines and devices which originally speak different languages in a factory, for example, to communicate with each other. It's the same thing in a lab as well. The next one being LADS, Laboratory and Analytical Device Standard. That's an acronym, LADS, we say usually, and it's a manufacturer independent and also open standard for, in this case, analytical and lab devices. It covers various industries, although there is a stronger need in the pharmaceutical and also life science and biological industry for such standards. And it offers an application that means it will meet the future requirements of digitalization and automation. It is very specifically designed for devices in labs so that they can easily work together. On a similar definition, SiLA, standardized in lab automation. This is an open communication standard for networking or connecting software systems in labs or lab equipment. SiLA is also an organization, and it has set itself a goal that is to create international standards to enable open connectivity in lab automation, basically. There is another version on the previous slide. I called it SiLA 2. SiLA 2 is a microservice framework and is based on also on an open and established communication protocols. Basically, to summarize it helps lab equipment from different manufacturers to work together by providing a standardized set of instructions. And finally, the last one, AniML, it stands for Analytical Information Markup Language. This is a new standard for analytical chemical and biological data, usually. It's a combination of different things. It has a scheme, a procedure, and a set of techniques, and also extensions in it. It's basically another way to define the standard. Now, what are the lessons learned when we talk about standards? Well, first of all, infrastructure. Very important. If you're looking at using standards in your lab, make sure that the necessary network and also the infrastructure is in place in your lab or in your company to connect the devices, right? It may include things like setting up a network, servers, and security protocols, but it's very critical. Another one is to do an inventory of any existing lab equipment. Why? Because if you have a complete overview of your available equipment, you will understand which one can be connected and which one may need to be upgraded or even replaced, right? How do you do that? You just conduct an inventory, you document the devices with information such as manufacturing date, connectivity options, firmware or software version, and in any case, you can also contact the manufacturer. Then the selection of appropriate standards. Choose the right standards because it's crucial to ensure the smooth and working communication between devices. How do you do it? You have to inform yourself which are the standards that are the most important. I'll come back to this later as well. And finally, do a pilot project. Why? Because you have to minimize your risks. A pilot is helping you to do this, and it also brings you or make you gain practical experience before the entire lab is connected, right? You don't want to start with a full lab right at the beginning. You want to do a step-by-step integration, and that's how you do it. So that's about the lessons learned in the standards. And as I mentioned, I want to talk about 3 categories. Standards was the first one. The second one is going to be the interfaces. So interfaces are basically a way to connect softwares to each other, right? These software usually work without the others. So it means they're completely independent. And if you use an interface, they can work together. And this is exactly what's happening here on the top of the picture. You have so-called application programming interface or APIs, but you also have other type of APIs. I want to focus on APIs today because these are basically the most relevant and important ones in our lab world today. What are the most important ones? Web APIs. Out of the four main categories, these APIs enable communication between different servers using the internet. Web APIs, they usually often use protocols such as HTTP or HTTPS, which you may know from browsing the internet and surfing online. You always see in the URL bar, there is a HTTP before any URL. The next one is called a library API. These APIs are included in software libraries usually that provide specific functions for developers to be integrated into their applications. These are standard libraries, as an example, in programming languages, such as STL in C++ or Java standard library. It basically helps developers or people developing applications to manage common tasks, such as working with data structures or processing files, or even creating network requests. Another category would be operating system APIs. These type of API allow an application or allow different applications to interact with an operating system. So most famous one is a Windows API, which enable any application to interact with Windows while working. And the final one is the database API. These are applications enabler. They enable basically the communication between application and software and databases. For example, you send requires to a database and you retrieve the data. There is some basic differences to be noted, maybe, because it's very technical. Web API communicates with the internet using protocols. A library API is part of a software library and it communicates internally with an application. The operating system API, it just enables communication between an application and the operating system, such as Windows. And a database API is enabling communication between an application and a database. Now, what did we learn talking about interfaces or APIs? Well, first of all, you have to have a look at the direction. Are you talking about unidirectional software interface that allow the data to flow only in one specific direction? So in this case, for example, software A provides the data and software B accepts it. Or is it a bidirectional software interface, which, for example, are designed to have an exchange between software A and software B? Another thing, the data transfer. Should the data be exchanged in real time or only at regular intervals? So what is your need? What do you want? What you're searching for? Because it has an influence on which technology you want to use. Same way, the data volume, like how large is the amount of data to be exchanged using this the interface you are trying to select? Because combined to the data transfer model behind it, it will probably reduce the options you have. And finally, what is your strategy? An interface strategy is referring to how you plan and implement your interface solution. And a successful strategy, in our opinion, should take into account various factors. For example, the requirements of systems and devices, but also available standards and types of data to be transferred. Right? So it's not just one thing, it's really different requirements. So these are maybe the 4 recommendations we would have if you are dealing with searching for a new interface to connect your lab. These are 4 things, 4 subjects that need to be addressed during the process. The final chapter is the data formats. And data formats happen to be the layer between the equipment before they're being transferred using any standards. And it's an essential topic actually for anyone who comes into contact, like gets in touch with a wide variety of data types and structures. Why? Because in the world of data, the format is crucial. Data formats determine how information is stored, how it is transferred and interpreted. So they not only influence the efficiency and the accuracy of our analysis later on, but they also influence the interoperability between different softwares and devices, especially in the testing lab, where the precision and the reliability are the top priorities. The deep understanding of the different formats is really essential. Of course, we could talk about a great number of formats, but today I think I would prefer to focus and also familiarize ourselves with the most important and most commonly used formats that are used basically in a wide variety of labs, right? So we're talking about ASCII formats, which can be found in almost every digital system. We're talking about REST APIs, which we touched a little bit before, database, and also encrypted formats. To give you another definition, the first one is stands for American Standard Code for Information Interchange. It is a basic but a very widely used format for text data, and it's characterized by its simplicity, readability, and also the compatibility with various systems and applications. A database is, as a data format, a structured and also efficient method of storing and managing the data you have, and it offers a very powerful query capabilities, high data integrity, and also security, which is very important, and it supports a multi-user environments. Databases store data in a very structured form. They're very often in tables containing rows and columns. And each row represents a data record and each column represents an attribute. That's usually how it works. A REST API, which we have been talking before. REST, by the way, stands for Representational State Transfer. And API, again, Application Programming Interface. And a REST API is a very, very powerful and also flexible architectural style to design a network communication that can enable efficient and scalable data transfer. Because it's resource-based, it also has stateless interactions, and the data is viewed in these APIs as resources that are identified with a unique URL, and each resource can be uniquely addressed by URL. So that's a very powerful one. And finally, encrypted data formats. While encrypted data formats are crucial for any data that needs a high level of security because it provides a protection against unauthorized access and manipulation, they're based on what experts or specialists call robust cryptographic algorithm, but also protocols that are widely used in data transmission. And we're talking here about the encryption, the security protocols behind it, and the authenticity, and so on. So these are the four main categories, I would say, that you should know about, including the definition. And what we learned, it's more a recommendation in this case than a learning, to be fair. First of all, if you can, go for open APIs. So go for APIs because it's an interface that is provided by the manufacturer of your testing equipment. It's currently very rare still, but we know from many, for example, European manufacturers that they are working with a lot of effort on this topic. If you don't have an API, use a database. If there is any possibility that your testing equipment provides you with a small database, ideally with an SQL database, which is a good format because you don't need files anymore. You just connect the database to your software solution and you don't have to exchange files anymore. If you don't have a database, go for the open files, which means any open data. It requires a small process to be imported into a software solution such as LabV, for example. Why? Because you have to first read out the data. It's called extract. Then you standardize them, which is called transform, and then at the end it's read by the software, which is called load. So there's an ETL process, a very common process in the database world as well. And finally, really, if you have no choice, use encrypted files. But to be very honest, these are usually just containing binary information, so the 1 and 0s, and it's usually extremely difficult to use them. if not completely impossible. So this is maybe the recommendation, if I may do one. Just go for open APIs. If you can't, go for a database, and if you can, go for open files such as CSV or Excel files, but try to not accept any encrypted file format from any manufacturer. To close up this webinar in today's information round, I would like to share 4 more learnings with you, which we learned from customer projects so far in the last years. First of all, go for the open formats. Open data formats are the formats that ensure interoperability and compatibility between different systems and also applications. They facilitate the exchange and also the long-term accessibility of data. That's extremely important. They avoid any kind of vendor lock-in, and they reduce the cost, of course, because there is no proprietary licenses required. And with an open format, you actually working towards a good and full transparency of the data structure, which supports, for example, compliance with any kind of regulatory requirements. API over data. As I mentioned before, testing devices, lab equipment with APIs enable a much easier integration and also automation of any kind of test sequences, and also enable you to have real-time access to the current data. So they offer a better, I would call it, scalability and also expandability for future requirements. They facilitate data acquisition and processing. You have the full control and the full monitoring capabilities of the device as well if you need, which is why we would recommend that the most successful lab connectivity projects are the ones using open formats and also APIs. If you have to choose a standard, in some cases you have to always go for the leading one, because basically the higher a standard is accepted in the industry, the more providers are going to support it. And it's also kind of future-proof, right? The leading standard is not going to disappear very quick, and it helps you to benefit from a continuous further development. And finally, always be modular and scalable. It's a little bit software buzzword in this case, but actually, if you rely on a modular and scalable system, you will be able to react very quick and flexible to the future and your future requirements, and also adapt your lab infrastructure as needed, because your lab is going to change and evolve over time. You can add with a modular architecture new components or new systems, or remove them very easily. And a scalable architecture is basically a support for growth, more equipment, more technology, and new technology advancements, such as, for example, artificial intelligence. Other than that, of course, here in the background, we think about the increasing role of cloud solutions that offer even more flexibility. And for cloud applications, you need APIs and you need scalability and also modularity. Well, that's it from our side. If you have any questions, please feel free. There is a Q&A function here right on the top of your window. If not, thanks for spending time with us today. I hope we were able to help you and give you some new information and insights about connectivity and standards in the lab. Don't forget, if you want to review this video, it is going to be available online very, very soon, probably in a couple of hours, just right after today. Thank you very much.